Okay class, settle down, settle down. Welcome to another exciting session of Software Development Fundamentals. Today, we're diving deep into the essential groundwork that every professional developer needs to master. We're talking about configuring your development environment and then, critically, selecting and configuring your versioning tools. This isn't just theory, this is the bread and butter of a smooth, collaborative, and efficient development workflow. We'll be using plenty of technical English terms, so pay close attention. These are the words you'll hear in every stand-up meeting, every code review, and every project retrospective. Alright team, let's kick things off. Our first major topic today is configuring development tools. Think of your development environment as your workshop, and your tools are the specialized instruments you use to craft amazing software. A well-configured workshop means less friction and more productivity. So, what are we talking about here? Primarily your Integrated Development Environment or IDE. This is your central hub for writing, debugging, and testing code. Popular choices include VS Code, IntelliJ IDEA, Eclipse, or Sublime Text. Each has its strengths and weaknesses, and often the choice comes down to personal preference or project requirements. Let's walk through a common setup with VS Code. First, you'll download the installer from the official website. The installation process is typically straightforward. Just follow the on-screen prompts. Once installed, the real fun begins: customization. Inside your IDE, you'll want to install relevant extensions or plugins. For example, if you're working with Python, you'll definitely need the Python extension for syntax highlighting, linting, code completion, and debugging capabilities. For JavaScript, you'd grab extensions for ESLint or Prettier to enforce code style guidelines. We'll also adjust our settings. This could involve changing your color theme for better readability, configuring font size, or setting up key bindings. Custom keyboard shortcuts to speed up common tasks. Think about your code formatter. Tools like Black for Python or Prettier for JavaScript will automatically format your code, ensuring consistency across your code base. This is crucial for readability and maintainability, especially in team projects. Beyond the IDE, we also need our language runtimes and compilers. If you're developing in Node.js, you'll need to install Node.js itself, which includes npm, the Node package manager. For Python, you'll install Python and usually pip Python's package installer. Java developers will install the JDK, the Java Development Kit, which includes the JRE and essential development tools. It's vital to ensure these are correctly installed and added to your system's path environment variable. This allows you to execute commands like Node or Python directly from your command line interface or CLI, regardless of your current directory. A quick Node, V or Python, version in your terminal will confirm their presence. Now let's shift gears to something equally, if not more critical, for any serious software project: versioning tools. This is how we track changes to our code base, collaborate effectively, and crucial for any developer undo mistakes without pulling our hair out. Our second topic is selecting versioning tools. In today's software development landscape, there's one dominant player: Git. While other systems like SVN, Subversion, or Mercurial exist, Git has become the industry standard for distributed version control. Why? Because it's robust, flexible, and designed for collaboration. With Git, every developer has a full copy of the repository locally, meaning you can work offline and commit changes independently. When you're ready, you push your changes to a remote repository, often hosted on platforms like GitHub, GitLab, or Bitbucket. These platforms provide fantastic features for code hosting, issue tracking, pull requests or merge requests, and CI/CD pipeline integration. Choosing between GitHub, GitLab, or Bitbucket often depends on your team's specific needs and existing infrastructure. GitHub is incredibly popular for open-source projects. GitLab offers a comprehensive DevOps platform with integrated CI/CD. Bitbucket often integrates well with Jira for project management. No matter which platform you choose, the underlying principle is the same: to manage changes to your code in a structured, traceable way. Imagine you're working on a feature and suddenly, you introduce a bug. With version control, you can easily revert to a previous working state. Or, if a colleague makes a change that breaks your build, you can pinpoint exactly what was changed and who changed it. This is the power of traceability. Finally, let's talk about configuring versioning tools. Since Git is our go-to, we'll focus on setting it up. First, you'll need to install Git on your system. It's available for Windows, macOS, and Linux. For Windows, you can use Git Bash, which provides a Unix-like command line environment. On macOS, Git often comes pre-installed, or you can install it via Homebrew. Linux users can typically install it using their distribution's package manager, like apt for Ubuntu or yum for Fedora. Once installed, the very first thing you'll do is configure your Git username and email address. These are essential because every commit you make will be tagged with this information. We do this using the git config, global user.name, and git config, global user.name commands. Make sure you use the same email address associated with your GitHub, GitLab, or Bitbucket account. Git config, global user.name, your name, git config, global user.email, your .email at example.com. Next, for secure communication with your remote repositories, you'll often set up SSH keys. This eliminates the need to type your username and password every time you push or pull changes. You'll generate an SSH key pair, a public key and a private key. The public key is added to your Git hosting service, GitHub, GitLab, etc. And the private key stays securely on your local machine. This is a crucial step for maintaining security and convenience. You'd use commands like /keygen to generate the keys, and then copy the public key content to your profile settings on GitHub or GitLab. This establishes a secure, passwordless connection. Finally, you'll be performing basic Git operations. This includes initializing a new repository with git init, staging changes with git add, committing changes with git commit, your commit message, pulling updates from the remote with git pull, and pushing your local changes to the remote with git push. Understanding these fundamental commands is your gateway to effective collaboration and robust project management. We'll delve much deeper into Git commands and workflows in future lessons, including branching, merging, rebasing, and resolving merge conflicts, all critical skills for any professional developer. So, to recap, we've covered setting up your essential development tools like your IDE and language runtimes. Then we explored the critical role of versioning tools, specifically Git, and how to configure them for secure and efficient collaboration. These steps are not optional. They are the bedrock upon which all successful software projects are built. Your homework for this week is to set up your own development environment for a language of your choice and ensure Git is correctly configured. Create a new repository on GitHub and make your first push. If you encounter any roadblocks, don't hesitate to reach out. That's why I'm here. Class dismissed.